Hey students, today we're going to take a look at Unit 2.1 and 2.2. We're going to be interpreting scatter plots and linear regression, so that is a line of best fit. And the things that we're going to be able to do by the time we're done today is to graph bivariate data, interpret trends on scatter plots, draw the lines of best fit, create a trend line, which is the same thing as the line of best fit, and find and interpret correlation coefficients, and then make a few predictions. We want to start by reviewing what we remember about scatter plots. And as some of you said in class, the scatter plots are just a bunch of dots on a graph that has a x-axis and a y-axis that can represent any number of things. This one is representing length and success, comparing length and success. This one is comparing temperature and sales of ice cream. In one case, it seems to be going down. The relationship is going down as the length of time maybe, or success, whatever they're doing. And here ice cream sales seem to go up as the temperature goes up. We'll be looking at some of those things as well. So we have some vocabulary here: scatter plot, trend, correlation, explanatory variable, and response variable. Scatter plot is just that graph that a couple of them we just looked at that show bivariate data using points. A trend is the general pattern. We notice that they can go up, they can go down, or there can be no pattern, really. Correlation is either positive or negative, and it's how those two variables are associated. Either they are both increasing, as one increases, the other one increases, that would be a positive correlation, or as one increases, maybe the other one is decreasing, that would be a negative correlation. Then there's an explanatory variable, that would be the variable that causes the change to occur, and the response, of course, is that change that is occurring. Linear regression line, or the line of best fit, is the line that can be used to display our trend, and we use that also for predicting in different situations. That's going to tell us what line best fits the data that we have collected, or the dots that are on that graph. Then an interpolation is a prediction that corresponds to our y values, and it's given an x value that's within our domain, where the extrapolation is outside the domain. Now, to graph a scatter plot, I'm going to go through this with you. I have the steps here. I'm not going to just go through them right now, but we'll go through them in a moment. Our first example is about Rachel, who's running a concession stand at the park. She sells water bottles, and she's been keeping a list of the temperature for each day, the high temperature for the day, and the number of water bottles she sells. And she thinks there might be a relationship between the two. So she wants to investigate, and going to be doing a scatter plot to check this out. So here's the data, and I do have a scatter plot already put together for you. It's in Google Classroom, and you can open it up. It should look like this. When you open it, you won't be able to make any changes to it. You don't have editing rights, so you'll have to make a copy for yourself, and then you can do the things that I'm going to do here. So we can see that the high temperature and water bottles sold, I did already put that in for us, so I'm going to select that data, and then I'm going to go up to Insert, and I'm going to tell the computer I want it to insert a chart. It's going to take it a minute, and then it's going to insert a chart, and the chart is typically a line graph of some sort. And I can go over here on the right-hand side where it says Chart Editor. Because the chart is highlighted, I'm going to get the Chart Editor, and I want to tell it that I want a scatter plot instead of the line. And then I want to tell it, I want to make some customizations here, and we want to see if there's a trend. So we're going to go into the series section and say, okay, I'm moving this over just a wee bit for us, and going to ask if it would please make a trend line. And this is a line that is close to the type of Yeah, we just want a linear trend line, and we can change the color of it. And it is giving us information that would closely resemble the points in our scatter plot. I'm going to make it a little bit deeper color and a little bit thicker so it's easier to see. And then the neat thing about this particular program is I can label this so that I get the equation that this line is represented by. And that equation is listed here at the top. I'm going to move it over to the side and I'm going to make it a little bit bigger. And I do that in the legend. The legend, I'm going to tell it to please position it on the right-hand side of my graph and change the size. Here's the size here. I'm going to change the size to 18 so I can see it a little bit better. And so it gives me the blue dots are the water bottles that are sold, and then the red line is the equation y equals 4.4x, and then it's giving us plus, and then the value is minus 188, and that is the equation of the line. Okay, so everything is given to us in the equation of a line. So again, to repeat quickly, we select all the information that we want in the graph. We go to insert, tell the computer we want to insert a chart, and then to make the changes on the chart, the first change we make is in setup, and we want it to be a scatter chart. And then the customization is under the series and the legend tabs, and that helps us to get the trend line. We can change the color and the depth of that opacity, and then change the thickness so we can see it just a wee bit better. Okay, so she wants to investigate and see if there's any trends. So it looks like there might be. We want to know, is this bivariant data? And the answer is yes, because we're using two different variables. We have the temperature and the number of water bottles that are sold. And then it says, if the temperature reaches 68 degrees tomorrow, about how many water bottles do you predict will be sold? And to answer this question, we can go back to our chart of data and say, well, 68 falls somewhere between 65 and 71. So we can estimate that it's going to be somewhere between 102 and 130 bottles of water. Or what we could do is we could use the equation right here from that line of best fit, and we can actually plug it in to a cell over here on the spreadsheet. To do that, we would say equals 4.44, and then we would say times, which is shift 8, it's the star symbol, shift 8 times, and it was 68 degrees. And then I'm going to say minus 188. The computer is using the generic form y equals mx plus b to give us these numbers, but we typically will say minus 188, not plus a negative 188. And then when you hit the enter, you get 113.92. So that's about 114 bottles that you'll have to have on hand. Okay. And then she wants to interpret a trend in the scatter plot. And so there, what they're asking is, it seems to go up as the number of bottle sales goes up as the temperature goes up. And that's what we're looking at as explanatory and response variables. And then the trend lines are used to make predictions, and they work with the correlation of data. And we want to know what is the equation in slope-intercept form. That's what we want. And that equation is, I'm going to just type this in for us, it's y equals m times x plus b. And I'm hoping you guys are saying, oh yeah, we know that. Y equals mx plus b, where m is the slope and b is our y-intercept. So m is the slope of the equation, b is the y-intercept. And we want to know then, what is the slope formula? What is that? And some of you have seen this, I know, before. The slope is either rise over run. You may have seen it presented that way. If you've taken Algebra 2 or even a pre-calc class, you might have seen it as delta y over delta x, which just means the change in our y value over the change in our x value, or y1 minus y2 over x1 minus x2. Each of these between the equal sign mean the same thing. And it's basically just the rate of change. How quickly is something changing? So again, if we go to that line of regression, we've already done this. To get that line, you go to the series, and then you tell it to please put in the trend line, and we use the equation under the label so that we see the actual equation that we're looking for. And then that line can be used to help predict how much water Rachel should take with her depending on the temperature. Because you don't want to pack too much, but you also don't want to pack not enough. So you want to make sure you have approximately the right amount of bottles so you can sell them all. So it says Rachel is stocking her concession stand for a day in which the temperature is expected to be 106. So how many bottles should she pack? And our equation again is y equals 4.44x minus 188. And we get that from the chart that we put together from the trend line. And so we're going to plug in that 106 where the x is. And that's going to give us 282.64. So knowing that she's not going to sell a part of a bottle of water, she would need to take a full 283 bottles of water with her so that she knows that she's had enough, has enough on hand. And again, the hint here to substitute, we're substituting in that 106 for the x. Likewise, if Rachel knows that the temperature is going to be 83 degrees tomorrow, how many bottles should she take in this case? And we do the same exact thing. We're going to take 4.44 times 83 and then subtract 188. We get 180.52. So she needs to pack at least 181 bottles. Now, of course, she could take more, but this is the minimum she should probably bring with her for the day. So one more thing about that line of best fit is that it has a correlation coefficient. And this correlation coefficient is a value that they use in statistics to help us determine if that line that we have is a really good line for the data or if it's not so good a line. And so we find the R, we'll be able to find the R really quickly using this the Google Sheets. But if that value, it's called R, and it's going to be somewhere between -1 and 1. And that negative would be telling us that it has a negative correlation, and a positive would tell us it has a positive correlation. But if that absolute value is greater than 0.75, then the correlation is really strong. If it's less than 0.3, it's kind of weak. And if it's somewhere in between, then it would be a moderate correlation. So this is telling us right here, this part is telling us where to find or how to find the correlation coefficient. And it's located under series, and some of you might have seen a little checkbox that says show R squared. Now, before we go to R squared, I want to point out to you that we don't want R squared. We want R for our correlation coefficient. So what we're going to have to do is get the R squared, and then we have to find the square root of that. And for those of you that remember, if we have X, I'm going to try to write this out for you, X squared to get back to X, how do we find X? Well, we find the square root of X squared is going to equal X. Okay, remember that. So we're going to use this square root function in the spreadsheet. That's what the SQRT is, a square root. And we plug in the number we get for R squared, and that will give us our correlation coefficient here. So let's jump back to Rachel's spreadsheet here. And again, go to Customize, and we're under the section labeled series. So here's series, and if I close that up, you'll see they're all listed there. Open the series, go down to the bottom under trend line and the information where it says use equation. Click the box that says show R squared, and you'll see that an equal and then a number appears in your chart, and that is R squared. To change it to R, you have to come over to the spreadsheet, select any open cell, and then you're going to type in equals, then in capital letters, SQRT, and again, that's the square root. Then hit Shift 9 to get the left parenthesis. Type in that number 0.945. That's what we're trying to find the square root of. Hit your right parenthesis, which is Shift 0, and then enter. And you can see that the R, the correlation coefficient for this particular set of data, is 0.97, which means it's a pretty high correlation. It's a pretty high correlation. I'm going to change the size of that so you guys can see it a little bit better. But that's a pretty strong correlation to be 0.97. And it makes sense. If the temperature is getting warmer, then you're typically going to sell more bottles of water, water as well. So we can interpret that as a strong positive correlation. And here's a couple of other examples of correlations. So with this one, it appears as though it's a negative correlation. And this one doesn't really seem to have a linear correlation. There's kind of a bunch of crazy stuff going on there. And then we have the second set of data. This is an example 2, actually. An elementary principal compiled some data about 10 students. The first number represents a student's height in inches, and the second is the student's reading level. And then we're going to create a scatter plot of the data, and we're going to find the line of best fit, the regression line, and then determine if our correlation coefficient is a strong one or not so strong. So I have that listed on the spreadsheet as well. It's the second tab. And to make a new tab, you just hit the plus. There's a plus sign over here on your spreadsheet. It's not showing up on mine, but anyway, you should be able to hit the plus sign and get a new sheet. But here, we're going to select all the data, insert a chart. This time it is coming in as a scatter plot for us because that's what we've been doing. We go to the customize, and it looks as though it could be a positive correlation, but let's take a look. And we want to put in our trend line. I'm going to again change the color so it's a little easier to see. Make it a little stronger color and a thicker line. With the label, I'm going to label use equation, and then I want to see the R squared. I'll have to change it to an R, but we'll get to that in a moment again. And then we go to legend, and I want to position this on the right-hand side so it's a little bit easier for me to see the data. And to make it even easier, I change it to 18, size 18, the font size 18. Now the equation for this one is 0.26 times x minus 6.61. And we can use that equation would again be y equals 0.26x minus 6.61. Then we were asked to say this correlation coefficient, see if it's strong, but to find the correlation coefficient, we need R, not R squared. So we come over to an empty cell anywhere in your spreadsheet. You type it equals and then capital SQRT. Hit your left parenthesis. Type in 0.844, right parenthesis, and hit enter. Now this has a lot of numbers behind it, behind the decimal. So what you can do, I'm going to make it a little bit bigger, easier to see. What you can do is reduce the number or decrease the number of decimal places to the right of the decimal, and you can do that just by clicking that down to two decimal places if you like. So this is showing that there's a 92.92 correlation, which indicates that it would be a high correlation between a person's height and their reading ability or reading level. But we need to take a couple things into account, guys. So when you think about reading, short people are still learning to read because they're little kids. And as you get taller, you are more able to read because you learn the alphabet and then you learn basic words and so on and so forth. So this might not be the best correlation or the best two variables to look at here. This bivariate data may not be the best, but it should make sense that, you know, as you get taller, as you grow up from being a little kid to older, that you are reading at a higher level. However, if you look at, you know, just people who are full size, you know, and they get to their full height, you probably don't see that same kind of data. So just keep that in mind as well, that for this, they're looking at elementary school children and saying, well, yes, as the kids get taller, they're able to read better. That just kind of makes sense. It seems to me a silly little thing, but anyway, your assignment is on Google Classroom, and please make sure that you use Google Sheets. You can use the same one that we used with the two examples, and just make sure you put your name on there. And remember, this is a double assignment, so it'll be worth double the points. And if you have any questions, please just give me a buzz or send me a message, and I will help you out. Have a great day.